Okay, so a problem like this one, you've got a slightly soluble salt. So the situation is like this. You've got a solution, and then on the bottom here you've got this salt, and some of it is breaking apart and forming ions in the solution. Now when it breaks apart, we've got A3B2. So if I drew a picture of that, now I don't have any charges here, so I don't know what they are, but it doesn't really matter for this situation. But A3B2 will break into 3 ions of A and 2 ions of B. So the table setup would look like this. A3B2 gives 3A plus 2B. So not all of it, whoops, 2B. Not all of it breaks apart, just a very small portion of it, but for every one that does break apart, we'll get 3 A's and 2 B's out of it. So the initial concentration, well, if it's a solid, it's meaningless. It can't do anything there. Equilibrium, we'll look at that as well in a second. That's going to be 0 and 0 initially. Then the solid is still not going to have a concentration at equilibrium, but the A will have a concentration of 3Z, and the B will have a concentration of 2Z. So for every one that breaks apart, and you can look at Z as being molecules if you will, so for every, let's say 10 molecules break apart, then we'll get 30 A's and 20 B's. It's really supposed to be that simple. So we've got our table set up. Now let's look at the KSP expression. KSP is going to be A to the power of 3, B to the power of 2. So it's just going to be A to the power of the coefficient times B to the power of its coefficient. We go ahead and plug in our values as they appear at equilibrium. 3.8 times 10 to the negative 8 equals 3Z cubed. Now the whole thing is cubed, and 2Z squared, and the whole thing is squared. I will show you the full working here. So 3 cubed is 27, that's 27Z cubed, and that's times 4Z squared. 2 times 2 is 4, 2 squared is 4. If we take 27 times 4, that's 108, and that's going to be Z to the 5th. Right, now we're in a position to be able to solve for Z. So Z to the 5th is equal to 3.8 times 10 to the negative 8 divided by 108. Z is going to equal 3.8 times 10 to the negative 8 divided by 108. To do that, we take the 5th root, which is the same as to the power of 1/5. So to the power of 1 over is the root of that. If you put this in your calculator, it should come out to be 1.3 times 10 to the negative 2. Now this is the Z value. It's not actually the concentration of B. What we're looking for here is PB, which is going to be the negative log of the concentration of B in solution. But the concentration of B is 2Z, so we have to take that into account. So B is equal to 2Z, which is 2 times 1.3 times 10 to the negative 2. Which is 2.6 times 10 to the negative 2 molar. So that's B. Now PB is going to be the negative log of that. So it's negative log of 2.6 times 10 to the negative 2. And that would come out to be 1.58. The number of decimal places on the log is equal to the number of significant figures in the number we start with.